Okay, so today we're going to go over the alternate series test. Oh no, wait, we just did that in a prior lesson. So I mention it to explain our next test. Okay, so the alternate series test, and I'm abbreviating it as AST, is the 8th test that we went through for our course. And the absolute or conditional convergence test. Okay. Absolute or conditional convergence test is our 9th test. They tie in together. So the alternate series test is an interesting test. The alternating series is an interesting series in that when it converges, is it because all your positive answers and negative answers towards the end, okay, of your sequence just eliminate each other and that's why you get an answer? It converges to some sort of sum. Or is it that, just plainly it's the sequence itself, okay, and not the terms being positive or negative, okay, that ends up converging. So that's what we mean by absolute or conditional. So is it converging because of the negative and positive terms, or would it converge regardless? Okay, so if it converges regardless of the terms, it's an absolute convergence. Is it because of those positive and negative values? Then it's a conditional convergence. Okay, so let's take a look at the following examples. So the wording of the directions is different this time, so please make sure that you're copying it down. Determine whether each series is converges, take out the is. Let's try to cross it out there. If each series converges absolutely, converges conditionally, or diverges. Okay, so let's focus one at a time. Okay, and let's take a look at A. So we have the sum of -1 to the nth power divided by the cubic root of n plus 1 from n is equal to 1 to infinity. So in this particular series, we can tell it's an alternating series because we have an alternator, -1 to the nth power. So I'm going to proceed to go through the steps, okay, of determining. I have to determine whether it diverges or converges first. So I might as well just go through all of those steps. So a sub n in this case would equal 1 over the cubic root of n plus 1. So now that you have that, remember the next one is determining the limit. Okay, so you can do the cubic root of n. I know there's a plus 1 underneath, but it gives us an idea of what we're working with. And this is going to be 0. So then we're going to go on to see if it meets the next condition. And the next condition is where we compare the nth plus 1 term with the nth term. The n plus 1th term should be smaller than or equal to the original. So we can do a little cross multiplying to solve here. Oh, I didn't actually cross multiply. All right, so make sure you do that correctly. And there we go. Cubic root of, this is where we have the n plus 2. We can raise both sides to the 3rd power. And And we can subtract 1 on both sides. We subtract n on both sides. And this is true too. So we know that by AST, it converges. All right, so how do we know if it absolutely converges or conditionally converges? So that's the question. Okay, so here's how we do that. Okay, looking back in our conditions, in order to find the limit of a sub n, notice that I used the expression of 1 over the cubic root of n. So I'm just rewriting that a little bit. So you want to use a series that you're more familiar with, like we don't have to have the plus 1 there. And this is a p series. And p is equal to 1/3. And we know that 1/3 is less than 1. So this diverges. So if it wasn't for that -1 to the nth power, okay, then this would have diverged. So we say that this is conditionally convergent. I'm supposed to C-O-N convergent. Okay, for part I. They would have to, this would also need to be convergent in order to say that it was absolutely. Okay, this one is conditionally. So let's take a look at part B. Okay, so part B, make sure you get it down. The sum of the sine of n pi over 3 divided by n squared from 1 to infinity. So it's an infinite series. And you may be thinking, oh, there's no alternator, to talk about where it's like a -1 to some power of n. However, you should be aware that the sine of certain angles, it gives you like up to a +1. Or a -1. So we can write that as like the absolute value of n is less than 1. So that shows you got like a range of values there. Well, it holds true that if it's going from positive to negative values, that this is the alternator and it is an alternating series. Now I am aware that it's really n pi over 3, so I'm going to squeeze that in there. And I forgot, it can equal 1. It can equal 1. So if we were to take a look that this is an alternator, then let's take a look at the rest of our expression. A sub n would be 1 over n squared. And if we take the limit of that, as n approaches infinity, it does equal 0. If we were to take the n plus 1th term and compare it with the nth term, okay, it should be less than or equal to that. So if we cross multiply to solve, then we can take the half root on both sides, subtract n, and this holds true. So by the alternate series test, this converges. Okay, so is it because it absolutely converges, okay, or conditionally, only because it happened to have an alternator? So we're going to proceed to look at 1 over n squared, okay? This is also this sum, a p series, where p is equal to 2. Now, since p is equal to 2, and it's greater than 1, it converges. Okay, so now both answers are the same. Okay, so no matter what, this is going to converge. And so in this particular one, it converges absolutely. I'm going to abbreviate that. And let's start to take a look at C. So please make sure you get it down. Okay, in C, we have the sum of negative 1 to the nth power times n squared over the quantity of n squared plus 1. Over the quantity of n squared plus 9. Make sure you read a 9. And we're doing this series from the first term to the infinite term. So it's an infinite series, and it's an alternating one because we have negative 1 to the nth power. So that leaves us with a sub n to be n squared over n squared plus 9. Now, if you take a look at this one, we have to make sure it meets both conditions. So if I take the limit of a sub n, okay, I can use the limit of n squared over n squared to do so, and that's 1. That condition's not met. Okay, now that means that it's probably divergent, so we got to make sure that it makes sense. It does. So again, if we go back and this is not equal to 0, then by the nth term test, okay, this series, this one right here, I gotta erase that, diverges. Okay, so we kind of got a little example of each one here in A, B, and C. So hopefully you got a good understanding of it, and make sure you do the practice. Good luck.